A warm welcome to everyone. Today, let's look at the embedded domain overview. The agenda for today's talk would be what skills an embedded engineer requires, few examples of an embedded system, work of an embedded engineer, what is an embedded system, typical block of an embedded system, characteristics of an embedded system, applications of an embedded system, and leading players in this industry. Job roles expected in the embedded system field. What an embedded system is. Most graduates today go after the popular IT industry to seek a good career. Many students are not aware of the productive opportunities available in the field of embedded system. That's mainly because of the lack of awareness and the entry barrier. Most of the students in their academics have come across the word embedded system, but they lack in the understanding of what an embedded system is, how do they work, what knowledge and skills should be required to build a great career in this field of embedded system, which companies are working in this field, etc. What makes an embedded engineer different from a software engineer? Like software engineers, embedded engineers do coding, debugging, testing, and simulation. Unlike software engineers, embedded engineers work largely with hardware and often need to develop or configure a custom operating system which is unique to the hardware and memory map of the device. Embedded engineers must also consider the safety. For an example of an embedded system, if an airbag in a car is not triggered by the sensors when the vehicle decelerates with a force equal to hitting the solid object. Consider that the typical embedded system is a highly custom device. It's not a standard platform where there is a plenty of pre-written codes that a developer can just drop in and write a few lines of glue code. Most embedded firmware is custom, meaning that on a typical embedded project, a high percentage of the code is new code, meaning that more development time and more developers are required. It is very possible and highly likely that due to the number of new embedded devices that will be created, coupled with the fact that code reuse and the third-party libraries can't provide any significant relief to an industry where the majority of the code must be custom, that the world of the future will need more embedded firmware engineers than application programmers. What skills do an embedded engineers require? Embedded engineers generally come from electrical engineering, electronics engineering, and computer science background and have total command over the embedded architecture. The most common programming language used by the embedded engineers is C or C++. General skills include C or C++, that is, hardware related C programming is the bedrock of the embedded engineering. This includes knowledge of the processor, and the compiler do this behind the scenes. Understanding of operating systems. Embedded developers usually need experience in programming in embedded Linux or similar embedded operating systems. Knowledge of assembly language, competency in at least one assembly language such as the ARM or x86. Let's look at the other skills required. Basic electronics, microprocessor fundamentals like interrupt processing, registers, assembly code. Microcontroller fundamentals, ADC, DAC, timers, PWM, DMAs, watchdog timers, RTC. Memory hierarchy, CPU registers, cache memory, RAM, ROM, and input-output storages. Basic protocols like I2C, SPI, UART, LIN. Advanced protocols like USB, CAN, MOST, FlexRay. Software architecture for embedded systems, software design, software integration, and software programming. Basic FPGA or ASIC design and basic DSP. Embedded developers working on commercial IoT devices usually need experience with some of the following: HMI programming, audio stacks. Let's look at some of the examples of an embedded system. Think of an embedded system as an electronic device that assists you to solve a specific problem. Mobile phones, microwaves, coffee machines, refrigerators, air conditioning system, traffic lights, and remote controls are all the examples of an embedded system. There are many embedded systems in car, such as airbags, anti-braking systems, which is known as the ABS. What does an embedded engineer do? Embedded engineers typically have control over both hardware and the software design. Typically, this requires an in-depth knowledge of the embedded architectures. Definition of an embedded system. An embedded system is a combination of computer hardware and software, either fixed in capability or programmable, designed for a specific function or functions within a larger system. Embedded systems are computing systems, but they can range from having no user interface, for example on devices in which the system is designed to perform a specific task or a single task, to complex graphical user interfaces. Let's look at the typical block of an embedded system. An embedded system has the software part, the hardware, the combination of the two, which leads to the embedded computer. Usually an embedded system has three components, that is the hardware, application software, and the real-time operating system that supervises the application software and provide mechanisms to let the processor run a process as per the schedule by following a plan to control the latencies. Real-time operating systems defines the way the systems work. It sets the rule during the execution of application program. A small-scale embedded systems might not have RTOS. Let's look at some of the key characteristics of an embedded system. Perform a specific task, that is, they do the same job every time over their lifespan. An AC will function only as an AC and not as a microwave oven. It has to perform a specific task within the time limit. It must therefore perform fast enough, like a car's brake system. If it exceeds the time limit, may cause accidents. Another example would be if an ATM machine delays to give a response for withdrawal of money, then we may lose the money. They have minimal or no user interfaces. A fully automatic washing machine works on its own after the program is set and stops once the task is over. Some embedded systems are designed to react to external devices and act accordingly. A thermometer, a GPS tracking machine, etc. Embedded systems are designed to achieve certain efficiency levels. They are small sized, consumes less power, and is cost effective. Users are not allowed to make any changes or upgrading the embedded systems. Hence, they must rank high on reliability and stability. They are expected to function for long durations without user experiencing any difficulties. Microcontroller or microprocessors are used to design the embedded systems. Embedded systems need connected peripherals to attach input and output devices. Hardware of an embedded system is used for the security and performance. The software is used for its features. Let's look at the applications of an embedded system. Household appliances, automotive, medical domain, consumer electronics, avionics, defense sector, aerospace industry, smartphones, and robotics. Some real-life applications of the embedded systems are as follows. Telecommunications, like routers, satellite phones. Household appliances, like refrigerators, washing machines, microwave ovens, air conditioners. Medical equipments, scanners like those used for MRIs, CT scans, ECG machines, devices to measure blood pressure and heartbeat and the other parameters. Consumer electronics, televisions, digital cameras, computer printers, video game consoles and home entertainment systems like PS4. IC designs like the chip design, defense sector in which we'll be using it for the radar, sonar and for the night vision cameras. Automobile industry, fuel injection systems, anti-lock braking system, music and entertainment system and control for the air conditioners. Industrial applications wherein we will be using it for the assembly lines, systems for the feedback, systems for data collection. Aerospace industry, systems for navigation and guidance and the GPS. Avionics, the navigation, the display and the management of the multiple systems. When it comes to an embedded system, do you know who are the leading players in this industry? Let's have a look at it. Atmel Corporation, which was acquired by Microchip in the year 2016. Their products include microcontrollers, radio frequency devices, including Wi-Fi, symmetric and asymmetric security chips, touch sensors and controllers, and application-specific products. Atmel modified or specialized many of its products for the automotive market. These products include car access, touch control, radio, CAN, WAN, and LIN bus networking, battery management, high temperature drivers, and serial EEPROMs. HCL Technologies Limited. They make products across sectors including the aerospace and the defense, automotive, banking, energy and the utilities, healthcare, high-tech industrial manufacturing, consumer goods. Bosch. They make products for the automotive industry. Intel. They supply processors for computer system manufacturers such as Apple, Lenovo, HP and Dell. Intel also manufactures motherboard chipsets, network interface controllers and integrated circuits, flash memories, graphic chips, embedded processor and other devices which are related to the communication and computing. Sasken Communication Technologies Limited. Sasken is a specialist in product engineering and digital transformation. In automotive, it is the smart devices. Infineon Technologies. Infineon provides semiconductor products for use in powertrains, which is used in the engine and its transmission control. Comfort electronics like the steering, shock absorbers, air conditioning, as well as in the safety systems like the ABS, airbags and the ESP. The product portfolio includes microcontrollers, power semiconductors and the sensors. So here we have just mentioned few companies serving different industries. There are thousands of other companies in the field of embedded system which are offering various kinds of services, consultation and product building. All the companies who are into manufacturing of a chip, by default they are into the embedded system design. What are the job roles expected in an embedded system field? Embedded hardware engineer takes the responsibility for the design and overall quality of the hardware and provide leadership and guidance for junior engineers. Realization of complex system requirements to provide robust and reliable hardware solutions. Embedded software engineer. These include designing and implementing software of embedded devices and systems, designing, developing, coding, testing and debugging system software. It also includes analyzing and enhancing efficiency, stability and scalability of system resources. Embedded test engineer. Analyzing and enhancing efficiency, stability, scalability of system resources. Embedded design engineer. Embedded software engineering is the process of controlling various devices and machines that are different from traditional computers using software engineering. integrating software engineering with non-computer devices, which leads to the formation of an embedded system. Embedded firmware engineer. Firmware engineers create and implement instructions called as algorithms, which enables the hardware to function accordingly. They may alter, organize, and model the functionality of a software for a variety of industries, including the automotive, the healthcare, and the consumer electronics industries. I hope till now you've got an idea of what an embedded system is, what is the work of an embedded engineer, what are the different job roles you might get. This was just a brief overview of what an embedded system domain is. In the later 10-hour sessions videos, you will learn what are the different processors, different controllers available, working of these architectures, how to design an embedded system using these controllers or processors in brief. But to work in an embedded system domain, this brief knowledge isn't enough. You have to learn many things in detail, like interfacing different peripherals, interfacing different peripherals in the controllers, by which you can design a small embedded system by yourself without anyone's intervention, and detailed learning of this is available in the 80 hours module. If you remember in your academics, you started learning from the basics, from the basic architecture of 8051 or the 8086 for learning the processor or controllers. Here we will be learning about the ARM v4 architecture. You might ask me, why ARM v4 when there are so many other basic controllers available? ARM v4 is the gateway to learn RISC-based architecture, which is the basic architecture and is the best way to start learning about controllers. We can start learning from the ARM version 1, which is nothing but the ARM v1, but the ARM has stopped licensing the various versions like v1, v2 and v3. So when we want to learn something new, we should always start from the basics. After v1, v2, v3, that is version 1, version 2 and version 3, now the only available basic architecture is the version 4, which is nothing but the v4. In ARM architecture, we have three categories. First one, the low level, the second one, which is the mid level, and the last one, which is the high level. So let's start learning from the low level, which is v4. The above is covered in our 10-hour session video, and along with it, in addition, you will get a brief understanding of the microprocessors and the microcontrollers, basic assembly coding rules, architecture of microprocessors, register sets, basic C coding using the microcontrollers, and the comparison of C and assembly code. You will also learn why C has more weightage over the other coding languages like .NET, Python, Java, Core Java, Oracle, SAP, etc. You might have learnt C in your academics, but here you will come to know what is an embedded C, what are the rules, and why we call this as an embedded C. So once you learn this embedded C, you are on the right track to be an embedded developer. Along with this, you will also see the lots of tools which will be used in the industry by the developers in the embedded system domain. You might ask me one question here. ARM v4 has some free tutorials available online. Why I shouldn't go through this? Yes, you are right. There are so many tutorials which are available, but first, there is no detailed video tutorial available. Secondly, in the web part, you will just get a brief idea for few basic things and not for all the things, and that too not in in-depth knowledge. In the online videos which are available, you will never find sharing of the knowledge on the coding part with respect to the device or the tools used. Once you learn from here, not only you can design in LPC2129 board, but you can also design on different boards like the STM boards, Texas Instruments board, LPC2148 board, Infineon board, and the other boards. So now you might have got an idea that why I am telling you to learn v4 architecture first. which is the gateway for the risk-based architectures, which in turn is the gateway for your dream of being an embedded engineer. A detailed study of an architecture of microprocessor and controllers, coding, firmware, what are the industry standards, different case studies will be covered in our ATR sessions video along with the reference materials, many assignments, interview related questions in each and every module. When you get a good understanding from these videos, you can then solve assignments without any help and also can comfortably solve programs, and with the detailed 80 hours program, you are all set for designing a small embedded system by making use of any kind of controllers which follows the risk-based architecture. When it comes to complex applications where multitasking is required, for example, smartphones, automotive applications, etc., we require an operating system. So, in our detailed 80 hours program, you will learn the multitasking or the multi-threading, task synchronization, and many more, which will be useful for designing an real-time operating system. In an embedded system, bit is the least number. So, let's start from the bit so that we can create a byte. Now, I will brief you what benefits you'll get once you subscribe to our 80 hours module. Our detailed 80 hours content covers the following: ARM architecture, that is introduction to ARM 7, introduction to LPC 2129 board, GPIO, vector interrupt controllers, timers, ADCs, PWM, various protocols like UART, SPI and the I2C. Best coding practices like the data types and the operators, functions, preprocessors, arrays and pointers. Linux system programming, introduction to Linux, shared memory and the semaphores. You can also do mini projects on the following after you go through our 80 hours module: embedded project on ARM platform, incorporating standalone modules with wired or the wireless communication protocols, embedded projects on ARM platform for designing an authentication system for the lockers, ATMs and the point of sale POS machines. Sample FAQs and the discussion on the interview related questions are also covered in the detailed 80 hours content, which will help you to clear any embedded programming related test and interviews queries. Thank you.